Hi everybody, welcome back. Let us do some problems on complex numbers here. Uh, I'll be teaching you some of the concepts of complex numbers here. Uh, Now, if we let us directly go into the problems right away, wasting no time here. Now, if I if I take the problem like to find the least positive integer, let's find that for which I have, which is if I write down, that is 1 plus I. Okay, if I consider that 1 plus I divided by 1 minus I to the power of n, to the power of n. Okay, let us try to solve this here. Uh, is it the choices which is given here are which is 2, 4, 8, and none of the above. Let us find the solution for this here. Now, a given problem is this. So, let us take 1 plus I and 1 minus I. Okay, the conjugate of this would be 1 minus I plus I and 1 plus I. This, if I try to simplify this, I get 2I by this is I square. Now this is 1 square plus minus I square, which results to 2, which is I. Okay. Now, now let us put this 1 plus I, 1 minus I to the power of n, which is I power n. Here. So n is equal to 2 is the least positive integer here. So I hope you understood this. Let us move on to the next problem here. Okay. Now let us find the smallest positive integer value of n, for which I have again 1 minus I divided by 1 plus I to the power of n. Okay, let us find, and is purely imaginary with the positive imaginary part. That is, the choices are given A as 1, okay, B as 3, okay, and C as 5, and D as none of the above. Let us find the solution for this here. Sorry. Now, 1 minus I divided by 1 plus I, if you consider this, and the conjugate of this is 1 minus I, 1 minus I. Now, if I try to simplify this further, I get minus 2I by 2, which is equal to minus I, which is equal to minus I. So, 1 minus I divided by 1 plus I to the power of n, which is minus 1 to the power of I to the power of n. Okay, so this would be minus I, minus I, minus I, and so on, respectively. So for n is equal to 1, 3, 5, respectively. Here. So hence, the smallest positive integral value of n should be n is equal to 3. So the choice is B here. I hope you understood this. Let me move on to the next problem here. Okay. If I consider here, if I consider z as x plus iy, if I consider z as x is equal to iy, such that uh, mod of z plus 1, okay, is equal to mod of z minus 1, and the arg of z minus 1 divided by z plus 1 is equal to pi by 4. Then the choices here are x is equal to square root of 2 plus 1, pi is equal to 0, b x is equal to 0, comma y is equal to root 2 plus 1, okay, and c we have, which is x is equal to 0 and y is equal to root 2 minus 1, and d we have, that is x is equal to root 2 minus 1 and y is equal to 0. So these four choices I have. Let us try to solve this here. Now we have been given as z as x plus iy, and z is equal to z plus 1, mod of that is equal to mod of z minus 1, okay, which we can write this implies that x plus 1 whole square, okay, plus y square, okay, is equal to x minus 1 whole square plus y square. This implies that x is equal to 0. This implies that x is equal to 0. And arg of z minus 1 divided by z plus 1, which is pi by 4. Okay, so we have z minus 1, which we have done. For that, it is minus x minus 1 plus I y, okay, this will be r of this multiplies with x plus 1, okay, minus iy divided by x plus 1 whole square plus y square, which is equal to uh, pi by 4, which is equal to pi by 4. Let us further simplify this. So I get r of x square plus y square, okay, minus 1 plus 2 iy divided by x plus 1 whole square plus y square. After simplifying, I get this result. So which is equal to pi by 4, which is equal to pi by 4. Now y is greater than 0 and x square plus y square minus 1 is also greater than 0, and you have 2y by 2y by x square plus y square, okay, minus 1, which is equal to 1. Okay, so this implies that x square plus y square minus 2y minus 1 is equal to 0 for x greater than 0, and x square plus y square minus 1 again being greater than 0. The arc of this would be, that is, z minus 1 divided by z plus 1, which is pi by 4, which is given. Now for this, if I there is a arc of ABC and of the circle which is of x square plus y square minus 2y minus 1 is equal to 0. For x being 0, I get y. If I try to simplify it, I get uh, that is y, I get 1 plus or minus root 2. 1 plus or minus root 2 for y which is greater than 0. Therefore, you have y as 1 plus root 2. I hope you understood this. And the problem, it was given as the choice, which is uh, you have uh, which is x is equal to 0 and y is equal to root 2 plus 1. The choice is B here. The choice is B. Hence, we got this result. So let us move on to the next problem here. Okay, let me write down the next problem here. Now, if mod of z minus 2 divided by mod, that is z plus 2, mod of this is equal to n, is equal to n, when where n is a constant and n is not equal to 1, n not equal to 1, then the locus of z is it a straight line? Okay, is it a straight line or is it a circle or is it a parabola or is it an ellipse? Now since uh, z minus 2 divided by z plus 2 mod of the that equation is equal to n is purely a circle if n is not equal to 1. Okay, so hence B is the correct choice over here. Let us look into the next problem. Now suppose if we consider or if we let alpha alpha as z1 plus z2, beta as omega z1 plus omega square z2, and gamma as omega square z1 plus omega z2. Okay, where omega is a complex cube roots of complex cube roots of unity. Then let us find that. Okay, so we have alpha plus beta plus gamma, which is 1 plus omega square z1 plus 1 plus omega square z2. Okay, so this is 0 plus 0, which is equal to 0, since we know that 1 plus omega square is equal to 0. Now again, alpha cube plus beta cube plus gamma cube is equal to 3 times alpha, beta and gamma. So we can write this here. When you write all the substitution of alpha, beta and gamma, let me substitute that. So I get z1 plus z2 and beta omega z1 omega square z2, and this is omega square z1 omega z2. When I try to simplify this, I get 3 z1 z2. Okay, let us try to simplify this. So I get z2 square my minus z1 z2 plus z1 square. So this is the result which we get after simplifying it. Now this is again 3 times that of, if I simplify this, z1 cube plus z2 cube. Okay, now alpha, beta, gamma, I get z1 cube plus z2 cube. Also we have also we have alpha square plus beta square plus gamma square, which is equal to 6 times z1 z2. So alpha beta plus beta gamma plus gamma alpha, which is equal to minus 3 times z1 z2. So which is alpha cube plus beta cube plus gamma cube, which is equal to 3 times that of z1 cube plus z2 cube. So this is the final solution. Let us move on to the next problem. Okay, now if I have here z1, okay, Okay, the last step which I want to explain here once again, what we have discussed here is alpha square plus beta square plus gamma square is equal to 6 z1 and z2. 6 z1 and z2, and henceforth we got as alpha cube plus beta cube plus gamma cube, which is equal to 3 times that of z1 cube and z2 cube. So that's that. So let us move on to the next problem here. Okay, if z1, z, z2 and z3 are complex numbers, okay, if z1, z2 and z3 are complex numbers such that mod of z1 is equal to mod of z2 is equal to mod of z3, okay, which is we get this as mod of z1 plus z2 z3, which is equal to 1. Let us then find the value of mod of z1, z2 and z3. What will be the value of this? Let us find this. Let us find the solution for this. Okay. The complex numbers which are given z1, z2, z3 and the mod of this is equal. Okay, so these are equal, and also we have been given as mod of 1 by z1, 1 by z2, 1 by z3 is equal to 1. Okay, since since mod of z1 is equal to mod of z2 is equal to mod of z3, okay, also which is equal to 1. So z1 bar, okay, is equal to z1, sorry, z2 bar is equal to z3 bar is equal to 1, and we know that mod of z1 is equal to mod of z1 bar, and mod of z2 is equal to z2 bar. Likewise, we have mod of z3 is equal to z3 bar. Okay, so the mod of z1, z2, z3 is equal to z1, z2, z3 and its bar, which is equal to the individual one. You have mod of z1 bar, z2 bar, z3 bar, which is equal to, now this would be 1 by z1, 1 by z2, 1 by z3, so which is equal to 1. So hence we got the value which is equal to 1 here. Okay, so I hope you understood this. Okay, so thank you for listening. So we'll continue to do this complex numbers and some of the important problems. Please send an email the problems or the queries which you have. Thank you for listening.